So we've talked about the adiabatic process already, and I just want to return to it to make sure that we really understand how moisture is moving from low elevations to high elevations. And recall that the adiabatic process is the warming and cooling of the air um, based on compression and expansion. So when the air is expanding, it's cooling, and when it's compressing, it's warming. So we've got a nice warm parcel of air at the surface of the earth, and it begins to lift. And as it's lifting, it's less dense than the air around it, so it begins to expand. Consequently, as it is expanding, it is cooling. The cooling then is removing the calories to then start to the process that's going to lead to condensation of that water. So we are ascending and cooling air by expansion. That air parcel, as is lifting, is carrying water that was evaporated from the surface of the earth upward. When it reaches the lifting condensation level, it's going to deposit, just like a little conveyor belt, it's going to deposit that air at the lifting condensation level and form a cloud. At some point, that air parcel is going to then start to condense and warm, and it's going to be more dense than the air around it. It's going to then fall. It's falling back to the earth void of water. There's not much water, if any, in that falling parcel of air. So it's kind of going down empty, if you will. And it's going to then start to warm as it is moving towards the surface of the earth. And as it becomes warm, then it's going to expand at the allowing for the uptake of this nice warm parcel of air. It's going to excite the molecules of water at the surface of the earth, liberate those relationships, and evaporate that water out. That water's then going to be in that expanded parcel of air, which now is more buoyant than the air around it, so it's going to lift, and now it's going to be taking water up that evaporated back up into the column of air to then add to that cloud which is being generated. So what we see is that adiabatic process is delivering moisture to higher elevations to produce that cloud. The more air that is adiabatically being lifted, the more moisture potentially can be added to the atmosphere. So on a really nice hot summer day, there's lots and lots of atmospheric lifting. Because there's lots of atmospheric lifting, there's the potential to add a lot of moisture to the atmosphere. So we see this on June, July, August days where the morning is, has few clouds in it. Clouds start to build maybe 10, 11 o'clock in the day. Those clouds start to then become more and more voluminous, larger in size as we move through noon, 1 o'clock, 2 o'clock, 3 o'clock, and by 3 o'clock we have these towering cumulus thunderclouds which have been produced. This rotation then of lifting and falling air is what we call air turbulence. And we can really only generate clouds when we have a turbulent air body, where we've got lifting taking place. If there's no lifting, there's no cloud production.